Hey there, folks. Welcome back to episode 4 of this Basics of Web Development tutorial series. Over the last few videos, we've been working with HTML and CSS to build this fairly simple web page you see here. Today, we're going to shift our focus away from the web page a bit and start learning the basics of JavaScript. We'll circle back to the web page and add some JavaScript to it later on, but first we need to cover some core programming fundamentals and JavaScript syntax. JavaScript is the primary programming language of the web, so your browser is able to run it by default, but for now, we're not going to be using the browser, and instead we'll be running our code from the terminal. To do that, we'll need to install what's known as a JavaScript runtime environment, and we'll be using probably the most popular one, Node.js. It's free, open source, and you can download it from nodejs.org, link in the description. Once you have Node installed, you can open VS Code's built-in terminal using Control and Backtick, or Command and Backtick if you're on a Mac. When the terminal opens, this might default to a PowerShell terminal if you're on Windows, or something like Bash or ZSH if you're on a Mac. I'm going to be using the command prompt terminal because I just like it better, but any of these will work just fine. So to make sure that Node is installed properly, we can run the command node space -- version. And when you press enter, if you see a version number, then you're good to go. If you see an error message along the lines of node is not a recognized command, you can try restarting the terminal, VS Code, or reinstalling Node. And if you're still stuck, just throw the error into Google or ChatGPT for some further troubleshooting steps. But if all else fails, there are plenty of online JavaScript compilers you could use to follow along just as well. So once Node is installed and working, or you're ready to go with an online compiler, we can get started. The first thing we'll need to do is create a new JavaScript file to write our code in. So I'll just create a new file and we'll call this app.js. And in here, as a quick test, I'm going to write the line console.log, add some parentheses, and then a semicolon. The semicolon at the end is used to say this is the end of the statement, but with JavaScript, this isn't always necessary, as it's usually pretty good at figuring out where a line ends on its own. I like to include them anyway, mostly out of habit, but also just to avoid any weird edge case issues. So inside these parentheses, I'm going to add some quotes and then a little message, hello, tread. Now in the terminal, I'll enter the node command and then the name of the file I want to run, so app.js. And when I press enter, we see that the text hello tread has been written or logged to the console. Excellent. All right, so I'm going to add a couple more console logs here. We'll run the code again. Pro tip, you can use the up arrow to retrieve the last used command. And now we see that all 3 of our console line logs are logged. Sweet, but okay, what if we wanted to use a different name, something other than tread? Easy enough, we can just edit each line. There's only 3 of them, so that's no problem. Well, what if it wasn't just 3? What if there were thousands of these console logs and they were all scattered throughout the code? Really doesn't seem so easy anymore, does it? Well, to make our lives a little easier, we can use a variable. So just above these console logs, I'm going to write the line const username equals tread. And what I'm doing here is declaring a variable. Const is short for constant, and it's one of a few JavaScript keywords we can use to declare a variable. Then I'm giving it the name username. And finally, I'm using a single equal sign to assign the variable username to the text tread. Now I can edit my console log lines, and everywhere I've typed tread, I can now use the variable username, but I have to add it outside of the quotes and use a plus sign to piece them together. And when we run it, we see that the same 3 lines appear in the console, no different than what we had before. However, now I can just go up here to line 1, change tread to John, And once we save and run the code again, we see the same 3 lines, but instead of Tread, it's John. And to do that, we only had to change one thing. So a minute ago, I mentioned that const was one of a few keywords we can use to declare a variable, and the other two are let and var. So we could add let password equals password and var age equals 30. And these are all valid lines of code. Each one is declaring a variable. So what's the difference? Well, the main difference is that variables declared with the const keyword cannot be changed later on in the code. They are constant. So down here, if I wanted to reassign the variable username back to Tread, if we run the code now, we get an error message, type error, assignment to constant variable. We told the code we didn't want this variable to change when we declared it with const, and then we tried to change it. However, with let and var, we can reassign these all we want. So I could perhaps make the password a little bit safer and add some numbers to it. Still a terrible password, but you get the point. Or set age to 31 now that my birthday is come and gone. And if we remove the line causing the error, now when we run the code, it runs without issue. There's no errors to be seen. As for the var keyword, this is the original variable declaration keyword for JavaScript and has been around a lot longer than const and let, which were introduced in 2015. Var is still very widely used, though using const and let is just a more modern approach. For the sake of this tutorial, you can just think of var and let as essentially the same thing. Now, with these variable reassignments, keep in mind that just like CSS, JavaScript code is run from the top down. Well, mostly. We can tell it jump around a bit, but I'll get to that in a later episode. So if we add a console log here for the password variable, when we get to this line of code, the password variable is still only just password. We haven't reassigned it yet. We could add the same line after the reassignment. And when we save and run the code, we see that it shows as password on the first line and then password 12345 on the next. So if we take a look at the variable declarations at the top here, you see I've wrapped the text-based data in quotes, and VS Code has highlighted the text in this orangish color. And then for the age variable, I didn't use quotes, and the number appears in this greenish color. That is because these variables are two different data types. The text-based data is known as strings, and the number is, well, a number. In programming, we need to differentiate between the types of data we are using so that we can do different things with that data, such as using arithmetic on numbers or adding some characters to a string. Another very useful data type we can use is called a Boolean. A Boolean is simply true or false. That's it. It can't be any other value other than true or false. So as an example, let's set a new variable called isLoggedIn to the value true. So this variable isLoggedIn is a Boolean. It can only be true or false. You're either logged in or you're not. Booleans are incredibly useful for decision making, which we will cover in a later episode. In JavaScript, we have two other data types used to represent variables that don't necessarily have a value, and these are undefined and null. Undefined simply means that the variable does not yet have a value. So I could declare a new variable and give it a name, and this email variable now technically exists, but we haven't assigned it a value or defined it, so it's considered undefined. If we were to log this value to the console, it tells us the very same, undefined. Something to note here, I use the let keyword because when using const, you must assign the variable when declaring it, otherwise you'll get an error. Now, undefined means that the variable doesn't yet have a value, but we can use null to explicitly set a variable to a nothing value. It's sort of empty on purpose. So we could create the variable selected user and specifically set this to null. And we might assign a value to this later, like if a specific user is selected, but for now we haven't selected anything, so we intentionally want it to be nothing. When thinking about these two data types, you can think of undefined like I don't know yet and null like I know there is nothing. Now, circling back to data types with actual data, there are a couple of data types we can use to group data together. The first one I'll show you is called an array. You can think of an array like a list. We can assign a variable to an array using square brackets. And then inside of these square brackets, we can add multiple pieces of data separated by a comma. In JavaScript, we can even use different data types for the data inside the array. Not all programming languages will let you do that, but with JavaScript, no problem. The data inside this array might be numbers, strings, and a boolean, but the list variable we've declared here is an array. If we log this to the console, we can see that all of the data is written. However, we can access individual data points from within the array using what's called bracket notation. So in the console log, after the variable name, I'll add some square brackets. And then inside of the square brackets, we need to add the index of the data point that we want. The index is the position of the data in the array, but it starts counting from 0. So index 0 would be the number 1, index 1 would be the number 2, and so on until we get to index 5, which is the boolean true. So let's add a 3 inside of these square brackets here to get the data in the 4th position. And when we run it, we see that only the character A is written to the console. Another data type we can use to group data is an object. Objects are written in JavaScript object notation, or JSON, which is actually a very widely used way of storing data even outside of JavaScript. So we can create a new object and we'll call it user data. And then we'll use these curly brackets. And inside of these curly brackets, we'll be adding key value pairs. So we can add the key name followed by a colon and then the string tread. And then we can add additional key value pairs. We just need to separate them with a comma. Let's add birth year, 1994, and then is active to the boolean true. And just like arrays, console logging the object variable will give us the entire object. And then to access individual data points, we'll be using dot notation. So that's just adding a dot after the name of the object and then the name of the key. So I can get my birth year from the user data object by adding dot birth year. And when we run it in the console, we just see the number 1994, which was the value of the key birth year. All right, so now we have a bunch of data in various variables. What can we do with them? Well, one thing you can do is something called string concatenation, which is exactly what's going on with these 3 lines here. We're using the plus sign operator to concatenate the 2 or 3 strings together to make one larger string. We're stringing together multiple strings. As you might be able to expect, we can also use the plus sign to add 2 numbers together. We can use a minus sign for subtraction, an asterisk for multiplication, / for division, and a double asterisk for exponents. There's also one more kind of funky arithmetic operator we can use called a modulus operator, which is represented with a % symbol. This gives us the remainder of a division equation. Before I show you an example, I want to just clean out some of these console logs real quick. And so if I were to add console log and then 10 modulus 3, when I run it, you'll see that we get the number 1. And that's because 3 goes into 10 3 times with 1 left over. So the modulus operator returns us that leftover 1. This can be pretty useful for determining if one number is divisible by another by checking if the modulus result is 0. So for example, you could check if your variable modulus 2 equals 0, and if it does, that means the value for that variable is even. If it's not, then it's odd. Now, what if we had a string like this that only contained numeric characters? What can we do with that? Is it a number or is it a string? Well, to check, we can throw in the type of keyword here. And when we run the code, JavaScript tells us it's a string. But JavaScript is one of several programming languages that uses what's called implicit type coercion. This means that it will convert data types on its own without you asking. So we can actually use both strings and numbers in arithmetic equations without errors. So let me just add a couple new lines here. And let's see what these give us in the console. So we get 322, 223, and 19. With the plus sign, string concatenation always wins over addition. So in the first two examples, JavaScript is converting the number 3 to a string with just the character 3, and then concatenating it with this 22 string. In the last example, since we can't subtract strings, JavaScript converts the 22 string to the number 22 and then subtracts 3. With that last line, if we tried to use a string with letters in it, we get this, NaN, and this stands for not a number, because 22AVB minus 3 is not a number. If we wanted to be more explicit about things, we can also convert data types using JavaScript's built-in conversion functions as well. So, philosophical JavaScript question for you. When does 2 equal 2, and when does 2 not equal 2? Well, the answer depends on which comparison operator you're using. In JavaScript, there are two different operators we can use to test the equality of two pieces of data: loose equality and strict equality. So here, we're using two equal signs, which represents loose equality. The expression in the parentheses of this console log will return a Boolean, true or false, if the string 2 is loosely equal to the number 2. And it says true. On the other hand, if we add a third equal sign and make it a strict equality comparison operator, it now says false. So with strict equality, we are asking, is the string 2 the same exact thing as the number 2? And the answer is no, because they're two different data types. But with loose equality, JavaScript will attempt to use implicit type coercion before making the comparison. So it will convert the string 2 to the number 2 and then make the comparison. And the number 2 is in fact equal to the number 2. We can also flip the script a bit and replace one of the equal signs with an exclamation point, or a bang as it's known in the programming world, to test for inequality and ask if something is not loosely or strictly equal to something else. And then finally, we can use other relational comparison operators, which are less than, greater than, less than or equal to, and greater than or equal to. The relational operators will always try to use coercion if necessary. There aren't really any strict versions of these. All right, folks, I'm going to wrap this one up here. In the next episode, we're going to dive into some logical operators and if statements, and we'll start writing some code that actually makes decisions instead of just dumping data to the console. If you've learned something or you've just enjoyed the video, please consider leaving a like or subscribing. It really does help me out a lot. As always, you can find a copy of the code we wrote today on GitHub, and the link will be in the description. I'll be sure to add some comments to give the code a bit more context, since it really doesn't do much at the moment. Other than that, thank you again, and I will see you in the next one.